Hi Year 11, this is another video of triple science only chemistry content. First we're going to look at carboxylic acids. Carboxylic acids are organic acids. The carboxylic acid group looks like this. We have a carbon atom double bonded to an oxygen atom. It's also single bonded to an oxygen which is bonded to a hydrogen. We call this OH sometimes. So whenever you see carbon double bonded to oxygen and bonded to OH, you know you have a carboxylic acid molecule. We name carboxylic acids with the suffix anoic acid. In this case, there's one carbon, so we use the prefix meth, just like if we're naming an alkane. So this is methanoic acid. Here's a second example, 2 carbons, 1, 2. Here's my carboxylic acid group. Anoic acid, 2 carbons is F, so we get ethanoic acid. Finally, I've got one here with the carboxylic acid group. 1, 2, 3 carbons. I want you to pause the video and write down what you would call this carboxylic acid. I'm going to show you the answer here. Because it's 1, 2, 3 carbons, it would be prop, and then because it's carboxylic acid, it's propanoic acid. Propanoic acid. The second part of this video is looking at weak and strong acids. An acid is a molecule that when you put it in water, will release a hydrogen ion. So here I've shown a carboxylic acid molecule, this is ethanoic acid, and I've shown where we would break the bond for hydrogen to come off. We call this, in fact I'm going to add this word on, dissociation. Here I've written this as a chemical equation. I've got ethanoic acid, it's an equilibrium, so it's, reaction goes both ways. We have ethanoate ion and the hydrogen ion. Now in the case of ethanoic acid, when we put it in water, 99% of the molecules stay on this side. The hydrogen doesn't dissociate. It's only about 1% of the hydrogens will dissociate at any time. Remember, this is an equilibrium, so it's constantly going both ways. But this is the balance that we have. So we actually produce very little hydrogen ions, regardless of if it's concentrated or dilute. And therefore we call it weak because we only produce a few hydrogen ions. The opposite example is a strong acid. Here I have hydrochloric acid. I've shown here where we break the bond to dissociate the hydrogen. And for hydrochloric acid, we get very, very little of the original hydrochloric acid molecule. Nearly all of it, I've put roughly 100% of it, would dissociate to produce the hydrogen ions. So whether it's concentrated or dilute, we refer to it as a strong acid because it produces hydrogen ions from basically every molecule. Finally, I've got another example. Here's another weak acid. This is methanoic acid. It is a weak acid. I've written the equation here. Methanoic acid producing methanoate and a hydrogen ion. I want you to pause the video and write down which of these sides would we have a lot of in the equilibrium and which of them would we have very little of. I'm about to show you the answer. Because it's a weak acid, we would have a lot of the methanoic acid and we would have very little would dissociate to produce the hydrogen ions. So there we have a weak acid produces very little hydrogen ions and a strong acid nearly all dissociates to produce lots of hydrogen ions. The last part of this video is looking at esters. Esters are formed when an alcohol reacts with a carboxylic acid. You need acid and heat to make this reaction happen. We're going to look at how we name esters. So here I've got a picture of an ester. We can see here a carboxylic acid looking thing. And we can see here an alcohol looking thing. That's what we've made it from. Each of those parts contribute to the name of it. So the first thing I always do is I look for the carboxylic acid. I look where's the carbon that's double bonded to the oxygen. Here it is. And I would then count the amount of carbons bonded to that. So this side we've got the oxygen, we don't worry. I'll go from this carbon 1, 2 carbons in this chain with the old carboxylic acid group on it. So that's eth. And we give that group that name ethanoate. Just like I was using the name ethanoate here. The carboxylate group part of this is called ethanoate. The other part is the remains of that alcohol, and here we have just one carbon, and we name that meth, and methyl is how we do it in an ester. So this ester would be called methyl ethanoate because the alcohol was just meth, just one carbon, and the carboxylic acid that we used had 2 to make it eth. Here's another example. Here I've got the remains of a carboxylic acid, and here I've got the remains of the alcohol that have bonded together. Firstly, I'm going to look at the carboxylic acid. Here's my carbon double bonded to the oxygen, so it shows me the carboxylic acid was there. There's just one carbon, so this is methanoate. Let's remember that anoate bit again. The alcohol has got 1, 2, 3 carbons, so that'd be propyl. Prop for 3, propyl. So this ester would be called propyl methanoate. Finally, I've got one here. Here is another ester. I've got the remains of a carboxylic acid group here. I've got the remains of an alcohol here. Please pause the video and work out what you would call this ester. I'm going to show you what I would call the ester now. I start with my carboxylic acid group. Here's my carbon double bonded to oxygen. I've got 1, 2, 3 carbons, so I call that propanoate. What's left is the remains of my alcohol, which is 1, 2 carbons. There's the oxygen linking them. 2 carbons is F, so this one would be ethyl propanoate. Thank you for watching. If you have any more questions, please don't hesitate to contact me.